Okay. This lecture covers a brief introduction about the subject integral calculus as well as integral of the basic or the standard forms. Okay, let's start. Uh, in mathematics, we are familiar with many pairs of inverse operations such as addition and subtraction, yeah, multiplication and division, raising to powers, and the inverse operation is extracting roots, and also taking logarithms and finding anti-logarithms and so on. Okay. In this lecture, we will discuss the inverse operation of differentiation, which we call anti-differentiation. So it is logical to use the terms differentiation and anti-differentiation to mean the operations which must be the inverse of each other. The term integration is frequently used to stand for the process of anti-differentiation. So, same lang na sila, integration or anti-differentiation. And the term an integral or an indefinite integral is generally used to mean an antiderivative of a function. So an integral or an antiderivative, they are the same. Okay, so let's talk about antidifferentiation. Suppose we do the reverse of differentiation. Okay? Like, given a particular function, we find another function whose derivative is the given function. Okay? So, natay given a function ba? And then we think of another function na ang derivative niya is the given function. Okay. So, we'll have a sample problem about this later. Now, this is called anti-differentiation, and it is part of the larger process of integration. So, integration, which is the main topic of this chapter, is the second main branch of calculus, with the first one being differentiation. So, and we will see that integration can be used to find the area under a curve over a closed interval. We will discuss that one sa next topics na paano to, sa discussion na to, which has many important applications. So not only area, but other applications. So, again, anti-differentiation is the process of differentiation in reverse. Ba? So, given a function f of x, okay, muna itong given nga function, we determine another function, capital F of x. You can use other notation like g of x, h of x, and etc. No? Because all of them are functions of x. So for now, we will use small f and capital F. So given a function f of x, small f of x, we determine another function, capital F of x, such that the derivative of capital F of x is f of x, small f of x. Diba? So in symbol, this one, the derivative of f of x, capital F of x is this one, small f of x. So since reverse na operation siya, anti-differentiation is the reverse of differentiation. It means na if the derivative of this one is f of x, the antiderivative of this small f of x is capital F of x. Opposite man ba? So, pag dili pa klaro, ah, Let's have this example. This is our given function. F of x, remember, ang small na f, mo ni ang derivative. Ba? Derivative ang small. So, if f of x equals 2x, so derivative niya, di ba? 2x is the derivative. So, if we find a function in which ang derivative niya is 2x, then the function will be or must be x squared. So that the derivative of x squared is 2x. So therefore, x squared is an antiderivative of 2x. Ba? So, kinina function, capital F of x, which is x squared, is an antiderivative of small f of x, which is 2x. Since the symbol, since the derivative of x squared with respect to x is equal to 2x. So the antiderivative of 2x is x squared. Okay, I hope na clear na. Okay. However, other functions also have a derivative of 2x. Okay? For example, yan eh. Kini na function niya, x squared plus 5. Ang derivative sa x squared plus 5 is 2x. Ba? Another one, x squared minus 15. Still, the derivative of x squared minus 15 is 2x. Or this one, x squared plus 200. The derivative of x squared plus 200 is still 2x. Di ba? So, dili lang x squared ang function na ang yung derivative is 2x. You also have these functions, 1, 2, and 3. So, let us generalize. No? Therefore, an antiderivative of 2x is any function that can be written in the form capital F of x is equal to x squared plus c, where c is a constant, such as this, di ba? So, mo ni ang derivative, no? Mo ni ang antiderivative, x squared plus c. So, ang c na to, it could be positive 5, it could be negative 15, it could be positive 200, or it could be 0, such as this. Ang c na to, 0. So, x squared na lang siya. Diba? So, this leads us to the following theorem. Mo ni ang theorem. Okay? So, um, the antiderivative of f of x is the set of functions capital F of x plus c such that mo ni ang symbol niya or the derivative of capital F of x plus c is equal to small f of x. The constant c is called the constant of integration. Pero kay ang atong focus dire ka integration man. So dili ni mo atong focus or review lang ni sa ba. So i-rewrite na to. If f of x is an antiderivative of the function f of x, we write this one. The antiderivative or the integral. So, from a familiarized, I will use the word integral. Okay. The integral of small f of x dx is equal to f of x plus c. Kay inverse operation man. So, the derivative of this is this one. Yeah? Therefore, the integral of this is also this one. Bali man. Yeah? Integral of f of x plus c is the derivative of this is f of x. Integral of this is equal to this one. So, diri atong focus kay integral calculus man yun. So, this equation is read as The antiderivative of f of x, or the integral of f of x with respect to x, is the set of functions f of x plus c. Okay, the expression on the left side is called the indefinite integral. Okay, no? This is the indefinite integral. And this symbol is the integral sign and is a command for anti-differentiation. Integration or anti-differentiation, pareho lang ha. The function f of x is called the integrand. Kini, integrand ang tawag kanina. Okay. Let's have a simple example. Determine these indefinite integrals. It means na you have to find the antiderivative of each integrand. Okay. Remember, wala pa tayong nag-discuss o standard forms ha. We'll just use or we'll just kining i-test na to ang inyong background knowledge sa differential calculus ani for this sample problem. Now, I know that you have seen these integrands before being derivatives of other functions like ini 8, 3x squared, e to the x, 1 over x. Okay, nakatry na sa gumawa ni sa inyong differential calculus yan. Sige. Let's start with letter A. Now, remember this is small f of x which is derivative. So, if 8 is a derivative, kung derivative ng 8 mali, think of a function na ang iyang derivative is 8. Eh, I will give you 10 seconds to think. Think of a function in which ang derivative niya is 8. So maybe you already have your answer. The answer is 8x. Diba? Because the derivative of 8x is 8. Okay. Of course, we have plus c, the constant of integration. Letter B. If 3x squared is a derivative, think of a function na mao ni ang derivative niya. Naki-function. You differentiate, and the derivative is equal to 3x squared. Another 5 seconds. Okay. The answer is x cubed. Ba? Uh, so the derivative, since the derivative of x cubed is 3x squared. Letter C. If e of e raised to x is a derivative, what would be the function in which e of x is the derivative? The answer is e raised to x like happened. Because the derivative of e raised to x is still e raised to x. And then last, if 1 over x is a derivative, what would be the function such that 1 over x ang iyang derivative? And the answer is ln x plus c. Diba? Okay. Pero, dili mao atong objective nga guessing game, di ba? Dili ni siya mao. Uh, this is just a simple test sa inyong knowledge sa differential calculus, basic derivative. Now, the results, these results, 1, 2, 3, 4. The results of example 1 suggest several useful rules of anti-differentiation which are summarized in theorem 2. So, bale, instead na mag instead that we will guess each one of these integrals or antiderivatives, we'll use some rules para dili ta maglisod aning an answer. So, theorem to rules of anti-differentiation. Rule number one, the constant rule. Okay. So, these are the standard forms and you have to memorize these forms. Okay. This will be your basis man sa kining future na mga integrals. Complicated ones, no? Complicated functions, no? Like more multi-chain rule or other difficult functions, you will always go back to these forms, the standard forms. First is the constant rule. So, pag constant, okay, constant, integral of a constant and dx, the integral is kx plus c. The second one is the power rule. So the power rule is this. Uh, the integral of x raised to n dx is equal to 1 over n plus 1 times x raised to n plus 1 plus c. And this is only applicable, ay, applicable na siya for all values of n except negative 1. And every time you apply nimo ni, think about this. Okay? The power rule is a two-step process or involves two steps. The first one is raise the power by 1. Okay, x raised to n. Raised by 1, nahimo siyang n plus 1. And number 2, divide the term by the new power. So, ang x raised to n plus 1, i-divide nimo og the new power, n plus 1. So, always remember this when applying the power rule. First, you raise the power by 1, and then after that, you divide the term by the new power. Uh, Sige. So before we will discuss the other rules of integration, let us have this sample problem. Use the power rule of anti-differentiation to determine these indefinite integrals. Okay. Letter A, integral of x raised to 6 dx. B, integral of square root of x dx. And then letter C, integral of 1 over x raised to 5 dx. So, sa letter A, x raised to 6 man, di ba? So, okay, let's recall. Again, raise the power by 1 and then 2, divide the term by the new power. Sige. So, ang 6 plus 1, and then divide na to. This is the result. So, x raised to 6 plus 1, you divide na to plus c. And then you simplify 1 over 7 times x raised to 7 plus c. This is the answer. Letter B. So, square root of x. So, instead ng radical form, i-transform nimo to exponential form. Pag square root, it means na ang exponent is 1/2, di ba? So, inanid. Oh. Mo na nimong n, ba? 1/2. So, the integral of this, again, remember the two steps. Raise the power by 1 and i-divide it. Ana. X raised to 1/2 plus 1. Yan, mo ni mo i-divide. 1/2 plus 1. So, ang resulta ni 1/2 plus 1 is 3 halves, di ba? 3 halves. Pero ang denominator man, i-reverse ni mo, it becomes 2/3. So, Reciprocal niya. Reciprocal of 3 halves is 2 thirds. 2 thirds times x, 1/2 plus 1 is 3 halves plus c. Okay. Or if you want na i-return mo na siya to radical form, pwede rin. And last, 1 over x raised to 5. Okay. Now, remember na ang other power rule is delete ni denominator, numerator niya x raised to n. So, find a way na mahimo sa numerator. And you will use law of exponent, di ba? Sa algebra na kini pwede nimo isaka pero ang iyang power mahimo negative such as this x raised to negative 5 mo nitong n so pwede ta mo integrate using power rule mo ni. Always plus 1 ka raised by 1 man. And then negative 5 plus 1 mo na i-divide nimo. So ang result negative 1 1/4 x raised to negative 4 ba negative 5 plus 1. And then since negative ni ibalik sa himon sa positive, inaog na po siya. The final answer is negative 1 over 4 egg times x raised to 4 plus c. So, this is very basic. Oh, and you have to master this one. You have to master the power rule. The third rule is the natural logarithmic rule. Standard na niya. So every time maka-encounter ani, integral of 1 over x times dx, the integral of this one is ln x plus c. Basic ni siya, very basic. Or standard form. And then the last rule is the exponential rule. Duha ni siya. The first one is base e. The other one is base a. A is any number. So you have this integral of e raised to ax dx. A is a constant lang. Any number except 0. Okay, ma-define mo niya. So, munang integral niya, standard. So, you have to memorize this one. And the other one is base A. Pag A lang, A raised to X over ln A plus C. Okay. So, simple example, determine the indefinite integral of E raised to 6x dx. Just follow this one, no? Ang A na to is 6. So, it's 1 over 6 E. This one. 1 over 6 times E raised to 6x plus C. Okay. And we also have this one, theorem number 3, properties of antidifferentiation. So the first property is a constant factor can be moved to the front of an indefinite integral. Pwede siya ipagawas ba? More of similar as mag-factor out. Like C times a function times a certain function. No? Pwede rin na inani ang pagkasulat niya. C niya integral of f of x dx. So, ang constant, pwede rin ipagawas niyo. Property number 2, the antiderivative of a sum or a difference is the sum or the difference of the derivatives. Such as this. Napanin siya minus, no? Plus minus. So, duha ni ka function f of x and g of x. No? So, kung sum lang siya, Pwede rin mo individual mo, integral of f of x dx plus integral of g of x dx. Pag difference, f minus g minus ano siya? F of integral of f of x dx minus integral of g of x dx. So, kung encounter ka problem, it could be a combination of the two properties. Like, ang yung f of x nasa constant, ang g of x na po siya constant. So, in that case, you'll be able to apply this one, property 1 and property 2 combined. Ano, and also, aside that, pwede pa niya na you can use diri. You can use power rule, diri constant rule, or logarithmic, or exponential, depende sa problem. So, example number 4. Determine these indefinite integrals. Let's assume that x is greater than 0. Duha lang. So, integral of quantity 5 times x raised to 7 plus 4 times x raised to 4 minus 3 dx. And then letter B, integral of 3 plus 5x cubed minus 2x raised to 6 all over x squared dx. So, for letter A, this is a combination, okay? Combination of sum and difference, sum and difference. At the same time, natay constant one na eh. Kaya itong property number 1, nga pag naay constant, di ba? Oh, and ang x raised to 7, this is power rule. So, combination siya. So, by the way, gi-apply na to ang property number 2, sum and difference. We also apply the constant factor, kining C. At the same time, gina-apply na to ang power rule. Diba? So, inani yan, pag-integrate. Okay. Separate mo, individual, and then apply mo properties of integration and the different rules. So, igawas ni mo 5, and then integral of x raised to 7 using power rule, and then 4, igawas ni mo 4, and also negative 3, and mo na result. Diba? So, 5, and the integral of x raised to 7 using power rule plus 1, 8, niya i-divide ni mo. And then 4, integral of x raised to 4 plus 1, 5, i-divide of 5. And then, this is rule number 1, di ba? O, katong constant rule. And then simplify, ano ang final answer. Sa letter B, okay, since you only have one term sa denominator, pwede mo i-divide. Okay. So, i-divide ni 3 over x squared. Ang resulta, denominator ang x. So, himuon mo sa numerator, man-negative ang power sa x. No? From positive 2 becomes negative 2. And then 5x cubed over x squared, using law of exponent, makancel na x cubed over x squared, so x na lang. And then the third term, 2x raised to 6 over x squared, law of exponent, raised to 4 na lang na siya. Okay, such as this. 3 3 over x squared, or simply 3 times x raised to negative 2. And then 5 times x minus 2 x raised to 4. And then apply mo properties and the rules. Mo ang result. Plus 1, negative 2 plus 1 is negative 1. I-divide mo negative 1. And then 1 man plus 1, so 2 over 2. And then 4 plus 1, you have 5 over 5. And then simplify. This is negative 3, di ba? 3 times 1 over negative 1, negative 3. Pero kay x raised to negative 1 man, ma-denominator na siya. So it becomes 3 over x. Yeah. Negative 3 over x. And then 5 halves x squared, 2 fifths x raised to 5 plus c. Okay. So, mm, so my suggestion is you have to master this one. Basic man, para pag medyo complicated ng functions, ah, okay lang kay master man mo ang basic. Mo ang importante. Okay. So I hope that you have learned something from this. Next lecture na to, we'll deal with complicated functions. Uh, like, what if daily standard form? What shall we do? Ba? Um, we're going to apply some techniques. Okay. So, thank you for watching. That's all.